I want to start by going over this problem one more time. It's the one we did at the end of class on Friday. It's problem 21 in lesson 8. And I just want to go over the solution one more time to hopefully get everything a little bit more organized. So what I've done is extended my table of L's to include a table of P's so that it'll be easier to see what I've computed and what I can compute given what I know. So the first thing I notice is that I've got these two adjacent L's, and that's going to allow me to compute P92, right? The entry in this spot. So P92 is 900 over 1,000, which is 0.9. So Q92 is going to be 0.1. And then using these relationships that I'm given, I can then work out that Q92 without the bracket is going to be 3 times Q92 with the bracket. So 3 times 0.1, which is 0.3. And Q91 plus 1 is going to be 2/3 of Q92. So that's going to be 0.2. So P92 is 1 minus 0.3, that's 0.7. So that goes here in my table. And 1 minus 0.2 is 0.8, that goes here. And then 0.9 goes here. So I've got those 3 entries. All right, so next I think I will look at these 2 entries because I know their ratio is 0.7, which I just computed. So I can figure out L92. L92 is going to be 920 over 0.7, which is 1314.28. Okay. So that can go right here. Okay. Then let's see. If I look at these 2 entries, that ratio should be 0.8. So I can compute L91 bracket plus 1. And that's going to be 920 over 0.8, which is 1150. So that goes here. And then I think I can get, well, if I look at these 2 entries, I can figure out the probability in this spot. So if I look at P91 with brackets, that should be 1150 over 1250, which is 0.92. So that can go right here. All right, so once I have a P92, then I can get a P91, I can get a Q91 as the complement, so that's 0.08. I can get a Q91 without the bracket, that is 3 times 0.08. and I can get a Q90 plus 1. That's 2/3 of Q91. So that is 0.16, and therefore P90 plus 1 is 1 minus 0.16, so 0.84. So I can put that on my table. That goes right here, 0.84. Okay. And then, so now I think I can get my answer, because if I look at the ratio of those two, that should be 0.84. And I'm looking for L90 plus 1. So I'm going to have L90 plus 1 is equal to 1314.28 divided by 0.84. And that's going to be 1564.63. And that is my answer. The next problem I'll discuss is problem 22, which is a sequel to the problem we just did. So you're given the same information as before, and what we're asked for is L94, so the entry right here. So I can actually get that in two ways, right? Either by looking at the row in which, so the row with x equal to 92, or at the column Lx plus 2, because I know that 900 multiplied by a P92 plus 1 will give me L94. And I also know that 920 times a P93 is equal to L94. Now, I don't know either one of those probabilities, but I know that they're related, because I know from the relationship given in the problem, Q92 plus 1 is 2/3 of Q93. And so the same thing is true for the P's, since they're just one minus. So I'm going to have 900 times P92 plus 1, which is 1 minus Q92 plus 1. So 2/3 Q93. Right, that's this. And that is the same as 920 times P93, which is 1 minus Q93. And that's that. And they're both equal to each other because they're both equal to L94. And now the only unknown here is Q93, so I can solve for it. So I'm going to get 900 minus 2/3 of 900 is 600. Q93 is equal to 920 minus 920 Q93. Add 920 Q93, that's 320 Q93 is equal to 20. So Q93 is equal to 20 over 320, which is 1 over 16. Therefore, P93 is 15 over 16, and so I can get L94. That is equal to 920 times 15 over 16, which is 862.5, and that's what I wanted to compute. Here's another problem. This is problem 1 in lesson 8. Okay. So we want to compute 1 Q80 plus 1. And we can write that in terms of L's, right? So I want to know the proportion of those people that are alive at age 80 bracket plus 1 who survive to L80 plus 2, so that's going to be L82, but don't survive to 1 year later, so to L83. And I know L82 is given in the table, that's 900. L83 is not given. L80 plus 1 is given, 950. So the only one that I have to compute is L83. And, well, I can see that if I look at these two entries, I can compute P80 bracket plus 1, right? P80 bracket plus 1 is going to be 900 over 950, which is about 0.947. But I'm given that Q80 plus 1 is the same as Q81 plus 1. And so if I take complements, those are also going to be the same. So this is going to be the same as P81 plus 1. And therefore, I can figure out L83 because that's 920 times P81 plus 1, so times 0.947. And that is about 871.578. So we can put that in here, and then we can compute our answer, which is going to be about 0.02992. So that's the answer to this problem. Finally, let's look at this problem from the MLC exam, spring 2012. So you have this business, Lorries, that rent lavender limousines. And each year they buy 30 limousines. 20 of them are brand new and 10 of them are 1 year old. And these limousines get retired over time. And this table is telling you what percentages retire each year. So the selection age is the age of purchase, right? So we can work through what happens to the limousines purchased in a given year, right? So we've got 20 that are new, and of those 20, right, so they have a selection year of 0. And of those 20, 10% are going to get retired the first year. So after 1 year, 2 of them get retired, and you end up with 18. Then the next year, 1/6 of them get retired. So that's 3 of them. So now we're left with 15. And then the next year, 1/3 get retired. So that's 5. So you're left with 10. Then we start going down the ultimate column. So the next year, half of them get retired, and we're left with 5. And the year after that, all of them get retired. And so at the end of 5 years, none of the original 30 would be in service. Similarly, we can look at the 10 that are 1 year old. They have a selection age of 1. So, so I start out with 10, and then I follow this set of probabilities. So 10% again retire the first year. So 10% of 10 is 1, so I'm left with 9. Then a third of those get retired the next year, so that's 3 get retired, so I have 6. Half of those get retired, so now I have 3. And then 100% get retired, so I have 0. So we can see that of the original 30, let's put that in a different color, 30. In the first year, 1 year after the purchase, 27 of them are still in service, 18 plus 9. And then a year later, 15 plus 6, 21. A year later, 13. A year later, 5. And a year later, none of them are in service. So we want to know, we've purchased 30 limousines each year for the last 10 years. Right after the purchase of the 10th year, how many are in service? So I'm going to make a chart here, and so in year 1, right? So I purchased 30 of them, and then in year 2, I have 27 of those in service. In year 3, I have 21. In year 4, I have 13, then 5, and then 0. Then in year 2, I purchased 30 more. So in year 2, I have 27 of the ones I purchased the previous year, plus the 30 that I just purchased. And then of those 30, 27 are still in service a year later, then 21, then 13, then 5, then 0. So I do this for each year, right? I'm purchasing 30 in year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I purchase the 30 in the year 10, I still have 27 from the ones that I purchased a year ago and 21 from the ones I purchased 2 years ago, etc. So the total number in service right after I purchase the last 30 is 30 plus 27 plus 21 plus 13 plus 5, which I believe is 96. So that should be my answer.